So let's solve this inequality. No, this is this inequality is actually a rational inequality. There's a numerator and denominator. Notice how we have to be less than zero. So again, we're looking for values of x that make the left side negative. So we want to find a solution. So remember, with inequalities, though, our solutions are in the form of intervals. So some things we want to do is we want to find the zeros and the domain exclusion. So to find the zero, what we do is we set the numerator equal to zero. Because remember, to make a fraction turn to zero, the numerator has to be zero. So if I set x minus 1 equal to 0, if I solve for x equals 1 would be, that's actually going to be called a 0. We also want to find what's called the domain exclusion. We want to set the denominator equal to 0 as well and solve for x. So x plus 9, we set that equal to 0. X equals -9, that's going to be our domain exclusion. So we want to exclude -9. Now, what's interesting here, though, is this is where signs will change. Notice that if you pick x to be a -9 on the bottom, that makes the denominator 0. But if you go right of -9, say, if I like to go really right, so pick a positive value that's right of -9, notice that that bottom's going to be a positive. But if you go left of -9, like a -10 or a -11, notice that that's going to make the bottom negative. And remember, when you're working with fractions and stuff, that's multiplying and dividing. And remember, with multiplying and dividing, the signs will indicate whether your answer is going to be positive or negative in that sense. So this is where we have what we call sign changes in the numerator and denominator. So they're very helpful when we actually try to figure out the solution. So 1 and -9, so the -9 will be to the left, and 1 is going to be to the right. And since we're less than 0, we can't include the 1, but we're never going to include the -9 anyway because it's a domain restriction anyway, so we would never include the -9. So what we can do there is we can identify the intervals that meet the conditions of the inequality. To identify the intervals, what we can do is test the intervals. If we look left of -9, if we look between -9 and 1, and if we look right of 1, we can kind of see which of those intervals actually works. And the easiest way to do that is actually put this into the calculator. So I'm going to put y equals and then clear this off, and then in parentheses, I'm going to put x minus 1, and then divided by, in parentheses, x plus 9. By doing so, it won't give me fractions in my table, it'll give me decimals. So now if I go to my table, notice that 1 was a 0. But if you go to the right of 1, notice that you're ending up with small values, but looks like what we're having is since the degree of the top and degree of the bottom are the same, it's actually approaching, looks like 1 is what they're actually approaching. So, but they are staying positive. So we're seeing to the right of 1, the values are positive. If I go between -9 and 1, so if I go to the left of 1, notice that if you look at your y values, they're all negative until you get to -9, and then it gives me that error. So in between here, we're seeing that the answers would be negative answers. And then if you go left of 9, -9, notice that again, they're back to positives, and they're not really doing much of anything, but looks like they're approaching 1 again in the end. Looks like it's interesting. It kind of does some interesting things there. So yeah, but we're seeing that if you go left of -9, you're getting positive values again. So just looking at the sign changes on the table is the easiest way to do that. So again, we were looking for negative because we had to be less than 0. So that looks like we have to be between -9 and 1. So we do not include either endpoint. So between -9 and 1 would be our solution. And again, we could graph it and see what it looks like from a graphing perspective. And notice how we really need to change my scale back, zoom in number 6. And notice that we can't really see much past here because our isotope is a little bit more out this way. But notice how the graph does cross the x-axis. Notice how there is a 0 here. It looks like right at 1 is about where that 0 is, but it would be hard to see it without actually using your calculate button to find that 0. But notice how it doesn't go much past that. Notice how there's like this horizontal isotope across here at 1. Now, if I go back to the left a little bit, so if my window and change my x min to be maybe -25, or let's just call it -20. And let's go to, I think I typed a minus sign, -20. And if I make my scale go by 2s or something, you kind of see the graph over here this way as well. And notice that you can kind of see that since you're above the x-axis, and I think 9's out there somewhere, 2, 4, 6, 8, 9's over here. Notice that you are above the x-axis left of -9. And notice that you are below the x-axis until you get to about 1. And then it crosses over and goes above the x-axis. So you kind of see where the y values are positive, negative, look at this graph as well. So I'm feeling pretty good about what we wrote down as our solution.